the last 2 weeks, we have talked about the external diagrid and glass facade that will realize the twist of this building. Even normal diagrids are hard to construct, but this building's twisted form made it an even more complex job in fabricating, assembling the external diagrids, and cladding the diamond panels to the exact place. Every step was a challenge constructing this aesthetic design in and out of the building. It was the constructor's job to make this visually magnificent building come true. The building has lots of visual surprises, and one of the most important ones on the inside of the building is in the hotel lobby. From levels 18 to 33 of Capitol Gate Tower is a Hyatt hotel. In the hotel lobby, it has an aesthetic design of natural light coming in through the whole floor from the glass ceiling above. It can come through every floor because it has an internal atrium, which is a hollow mass inside the building. Originally, this atrium is not for the design, it's an essential structure point to resist overhang. We will talk about why it was needed, how it accomplished a very important role to sustain the lean. This internal hole was precisely planned to lose heavy weight of building's upper floors. Then why did it have to lose weight? There were mainly two reasons. The first was the designer's urgent request for an infinity pool. They asked for a 2-story cantilevered pool and restaurant deck hanging 90 meters from the ground, on the 18th floor of the building, on the opposite of the tilt. What was even more, they wanted this cantilevered structure hanging without any visual support. If this would succeed, it would become one of the highest suspended swimming pools in the world. Every aspect of this building was a challenge, and this was no exception. Because the water inside the infinite pool itself was over 150 tons, it makes headache to engineers. Then how could the cantilever succeed in hanging without visual support? If this massive heavy structure that the water inside the infinity pool itself was over 150 tons is cantilevered without any additional support, diagrid would get torn apart. It was necessary for additional support, but they had to also consider the designer's request to keep it suspended in the air. So, the structural engineers decided to use a second best solution. They would use hidden structures to support the cantilever deck from below. This swimming pool and restaurant was the only part in this building that external diagrid couldn't bear its load. So, it needed additional structures to transport the load to external diagrid. But to hide support, they couldn't install enough amount of support to uphold cantilevered structure totally. The idea behind these junctions is that they behave like the insects that can walk on water. They are sufficiently light, but the surface tension keeps them above the water, so these little brackets dissipate the forces from all that weight. In structure, 22 underpinned steel struts would do the job. They will carry the rods back into the building. As the cantilever would be more than 200 tons, the junction brackets would successfully minimize the load transferred to the leaned surface of the building. These struts also had to look delicate to meet the architect's aesthetic demands. With its cantilevered structure, it provides a unique presence on the skyline of Abu Dhabi, but also it made more stress to core and diagrid. And second reason is following. The taller it went, the more problems occurred. Let's take a look at how Capitol Gate Tower's upper floors take shape. We have mentioned about the twisted and leaned shape for weeks now. The building's weight of the side of the lean continued to be a problem, causing a dangerous overhang. Also, the floor areas get larger and larger as the tower goes up. Keeping this big-headed leaning tower was becoming a real problem day by day. Putting these two reasons together, the additional cantilever and larger space areas in the upper floors, the tower was just about to collapse. Even the pre-cambered core and post-tension tendons were not enough to stop this building collapse. The structural engineers felt the need for a diet. The tower had to find a way to lose some weight in the upper floors. This was when the architects came up with a clever solution. It was bringing in an internal atrium inside the upper floors of the building. As mentioned before, it would bring in light to the hotel lobby and give a magnificent design effect inside. And would also structurally help the tower sustain the lean, preventing it to topple over. The atrium would take place starting from floor 18th to the top floor, and it would have the shape of the funnel, the void getting larger as it goes up. Then why did the atrium have to be a funnel shape? It is due to the tilt of Capitol Gate Tower. As the building tilts up, it will have to stack up more, and the mass would become larger as it goes upstairs. But if that builds up, overhang gets stronger. Engineers install the same slabs on each floors and put the same size of hotel unit at the edge of the slab, which are attached to external diagrid. But for the tilt shape, the span between the core and edge of the slab was getting longer during going up. So the floors were stacked in a spiral shape along the exterior diameter grid of the building. And a funnel-shaped atrium was created, where the empty space grew from bottom to top. However, this funnel-shaped atrium rather complicated the management of the load and created other structural needs to support the atrium. They considered how to solve the unpredictable load channeling caused by funnel-shaped hollow core. It was critical in transferring loads from the internal diagrid to the core. In this, the engineers suggested an unconventional method to use diagrid structure inside a building. These days, constructing internal diagrid in tilting design is called the peak of the latest technology and is a very, very challenging process, even to experienced constructors. Overall, they mirrored external diagrid form to internal diagrid, but they didn't need to connect diagrid with diamond glass unit like external diagrid. So, they could change the form of section to channel load efficiently. They selected a section of circle internal diagrid member consisting of 80 mm thickness hollow section steel, because it is 20 to 50% cheaper than with open sections, and it channels much more uniformly in compression or torsion load. But it was still a challenge to link this with the central core. The internal diagrid was linked to the central core by 8 unique pin-jointed structure members. With this connection, they could channel the massive and unpredictable load made by urgent designers' request to the core stably. However, they faced another problem soon. This funnel-shaped internal skeleton carries the forces of an 18-story building down to its tapered base and into the core. But the loads are extremely high for such a small area. To stop the atrium punching through the core wall, the concrete needs protection. The answer is to bring in 6 giant plates of steel that breaks the connection to the core wall. These 6 giant plates are called outrigger. Outrigger is a structure system that connects the core wall and the external column. In our case, it's external diagrid. It helps to disperse the loads between diagrids and concrete core. If the tower does not have outrigger, the loads applied to internal diagrids cannot be dispersed to core and external diagrids. It means that capital gate tower should withstand the lateral loads applied by wind and moments from pre-cambered core and leaned angle with concrete core and diagrid separately. This could make serious accident on construction. But when outriggers are applied, effective span of structure system can be widened, single concrete cores to almost all of the towers. This improves the tower stiffness for lateral forces. So, the displacement decreases noticeably compared with the displacement occurred at concrete core alone. Outrigger is fixed at diagrids with belt truss. That is why core and diagrids can operate integrally that improves the tower's stiffness. But belt truss's size is too big that needs the heights of 2 to 3 floors. So, at the capital gate tower, it installed at 17th floor, occupied 8 meters, which was 2 floors height. Contrary to capital gate tower, is used as office, 16 floors, and used as hotel, starting 18th floor. It does not show the usage of 17th floor for people. But this thick tube had an important role at structure. This helps to sustain the tower safe and strong, even though it had cantilevered splash, T-lounge, and infinity swimming pool starting at 18th floor. Also, it dispersed the loads effectively from internal diagrids to concrete core and external diagrids. This prevents core wall punch through by the loads from atrium. With these all structures, they finally stacked all parts of capital gate tower. It was really hard job to realize impossibly tilted tower, but they made it. But capital gate tower was a revolution not only for its shape, but also its energy efficient facilities. So next week, we are going to talk about its system to maintain tower comfortable.